Implement Google Play's in-app updates feature in Unity. Now I'm pretty sure you must have searched for it yourself, but if not and you still somehow ended up on this video, then this feature lets developers prompt users to update their Android apps directly from inside the app without opening the Play Store. Now there are two types of in-app updates, immediate and flexible. Immediate update occupies the whole screen when an update is in progress, therefore users can't use the app until the update process finishes. Flexible update on the other hand runs in background, so while the update is being downloaded, users can keep using the app. With that said, let's jump right into Unity. I have this demo app. It's just a regular app with no in-app updates logic whatsoever. Hence this text in parentheses, which I'll keep updating time to time as we progress in the video. And this version number is automatically set during the runtime. All of these just so it's easier to keep a track throughout the video because I'll be generating multiple builds. And this button here on click just increments the on-screen number. Okay, before we even begin coding, we need to download the Google Play's plugin. The official documentation provides you 3 ways to get the plugin. I'm gonna download the Unity package from GitHub and then import it in the project. Let's create our script named app updater, and I'm gonna also create an empty game object with the same name. Attach the script to this game object and let's start implementing our logic. We need google.play.appupdate and google.play.common. Our entry point to in-app updates is through this app update manager. Let's create an instance of this inside the start method, and from here itself I'll start a coroutine to check for updates and handle accordingly. To get information about the updates, we need to make a network call via getAppUpdateInfo method, and let's store the result in updateinfo operation variable. If it fails, we log the error and get out of this coroutine. Else we store the result in update info. Now, update info holds the information if a new update is even available or not. If we explore the update availability enum, anything less than update available means we don't have an update and we can exit from here. But if we do have an update available, then we either start an immediate update or a flexible update. In this video, I'll set it up to support only one type of update at a time. Let's scroll back to top and create a serialized field to expose this app update type. This gives us a drop down in inspector. Based on the update type, we are gonna start the respective update process. First, we will implement immediate update because it's the simplest of the two, and flexible update requires a bit more work to set up and implement it. So we are gonna start a new coroutine for immediate update and pass our update info. App update options.immediate app update options returns the configuration necessary for immediate updates. Before we even start the download process, we are gonna check if the update is even allowed or not. Based on my research, it returns false in cases like when there's no network or device storage is low for downloading the update. Now we can finally start downloading the update by passing update info as well as the newly created update options. And that's it. We have finished implementing immediate update. I'll switch back to Unity and update the parenthesis text to first build with immediate. And don't forget to set the update type to immediate. Before we generate a build, go to edit, project settings, player, other settings, and bump up both version and bundle version code. Now let's open the build profiles, enable the option build app bundle Google Play, and let's generate a build. In order to install and test the build, open your app in Google Play console in your browser. Go to test and release, testing, internal app sharing. Get started if you haven't already used internal app sharing before. Scroll down to manage testers section and select restrict access to email lists. Now click on manage email lists, create email list, name the list and add your email ID. This is an important step. Use the same email address that you use for the Play Store on your Android device. Otherwise, you won't be able to access the build. Select your newly created email list and save changes. Now switch back to uploaders and testers tab and click this link. I'm gonna drag and drop the build we just generated. Join. In case you get this error, continue watching, else feel free to skip ahead. You need to finish these incomplete tasks you see in the dashboard before you can start using internal app sharing. Fill all of the million questions in there, including this privacy policy. For store listing, you don't have to set it up as if you were to release it publicly. For now, just fill it up with anything. This is my store listing. I filled it up with bare minimum stuff. My logo and these images I quickly mocked up. If you visit my Play Store profile, you won't even see this app listed here. Moreover, it took merely 6 minutes to approve my submission. Once you finish those pending tasks and submit the changes, you can retry uploading to internal app sharing. If it still fails, just make a release on close testing or internal testing track. Now that a build has been uploaded, copy the download link and share it with yourself via WhatsApp or whatever floats your boat. Before we open the link, we need to ensure we have the developer access. Open the Play Store app in your Android device, open accounts, ensure you have selected the account associated with the email ID you added in the testers list. Scroll down to settings, tap 7 times on Play Store version, and now you're in developer mode. Now go to general at top and scroll down a bit till you see developer options and enable internal app sharing. Okay, it's time to install the app now. Open the build link and I'm gonna install it since I don't have any prior version of the app installed on my device. Let's see. The app is working fine and it clearly states that this is the first version of the build that has the code to support in-app updates, specifically immediate update. Now to see it in action, we need to generate a new build and upload it to internal app sharing. So I'll go back to Unity, update this message to state that this is the second build with immediate update support. Pump up the version and bundle version code, build and upload. With the new build uploaded, I'm just gonna open my app in Android and nothing happens. No, nothing's broken, it's by design. We have to open the link of the new build and Play Store is gonna show we can update the app, but don't update the app from here. I'm gonna exit Play Store and restart my app, and as soon as I get into the app, boom, immediate update takes over the screen. And now if I click on this update button, it's gonna download, install and restart the app automatically. And here we go, successfully updated. Awesome. Now let's implement flexible update. I'm gonna collapse start immediate update and start a new coroutine for flexible update. Just like earlier, we're gonna first get the configurations for flexible update and check if update type is even allowed or not, and then start the update. Instead of yielding right here, unlike immediate update, we're gonna run a while loop until the update operation is done. Although Google Play automatically shows a progress bar in notification tray of Android device, but if you want to display a progress bar inside your app, then this is the place for it. You can hook into download progress, which has a value between 0 and 1, or access bytes downloaded and total bytes to download respectively. Once we are out of the loop, we'll use a switch statement to handle some of the operation statuses. If the status is downloaded, we are gonna show a UI to users in the app from where they can select to begin the update installation process. Why do we have to show a UI, you ask? Well, flexible update allows user to keep using the app while the update is being downloaded. Imagine they are midway through a level when the installation process suddenly starts. They would lose all their progress, and we clearly don't want to make them rage quit now, do we? Okay, so the current operation status could throw failed even if we already have the update downloaded. In this case as well, we need to show the UI to get user consent. But if the operation failed for some other reason, we can log it here for now. We're done with the core logic implementation and we just need to wire up our UI. Here, I have simply created this yellow button which on click should initiate the installation process. In the script, I'll expose a field of type button to hold a reference of the apply update button. And inside start, on button click, we'll start a new coroutine to apply the downloaded update. Before we implement the coroutine, I'll quickly remove all the listeners from the button inside on disable method and set the initial state of the button game object as inactive. Scroll down to our switch block and replace the to-do lines with the code to set the button game object active. With this, we are done handling the UI. All that's left is to implement our one last coroutine, apply flexible update. Our app update manager object has this complete update method, so we just have to call it. In case of failure, I'm just gonna log the error. If everything goes right, the app should restart by now. If it doesn't and control reaches this point, then you're so cooked. That was the last piece of code we write. I'll quickly add the button reference in the inspector, change the update type from immediate to flexible, and update the text to first build with flexible. Now here's the utmost important step you must do for flexible update to work. Go to your assets, Google Play plugins, com.google.play.app update, runtime, scripts, internal, and open the app update handler script. Now just scroll down to on application pause method and remove this app update manager internal.cancel request. The reason is when the update pop-up is displayed to the user, this method is called. When cancel request is executed, it tells our script that user has cancelled the update even if the user actually agreed to update the app. And the funny part is the update does download in the background. You can see it in the notification bar, but we no longer receive the correct update status. Unlike immediate update, flexible update does require us to explicitly call the complete update method at the right time. Now we are so ready to generate a new build. You know the drill. Bump up the version, bundle version code, build, deploy to internal app sharing, and copy the link. I'm gonna uninstall the app from my device and manually install the latest build. Here's the first build with flexible update logic. To see the flexible update in action, I need to deploy a new build. By now you can recall the whole process even in your sleep. Remember, open the link of the new build once, but don't click on update here. I'm gonna open my app now and here is the pop-up. If I click on update, you can see the update progress in notifications, and as soon as the download finishes, our button is rendered. Pressing the button initiates the installation process and the app restarts with a new version. And with that, we have reached the end of this video. But before you close it, I just want to say this tutorial focuses on a basic implementation of in-app updates. You can absolutely use it in production, but I really hope you won't. This implementation in terms of UX is an absolute L. I would recommend exploring the idea of update staleness and update priority rather than just hard coding one type of update in your app, especially one that triggers an update prompt as soon as you boot up the app. Because let's be honest, we're constantly ironing out bugs, and every new update would mean forcing users to deal with update prompts even when it's just a non-app breaking bug. Do you see the problem with this approach? In theory, update priority seems like a good idea. Deciding the update type based on it sounds simple enough, but in reality, it's a hot mess when you actually try to implement it. It's a complex process that you can't really achieve with just Unity, and Google's documentation is as helpful as a GitHub README that says just install the dependencies, bruh. This whole thing deserves its own video and I plan to drop it soon. I'll link it up here or in the comments once it's out. Okay, bye.